During the late 1800s, at the University of Ghent in Belgium, a chemist by the name of Friedrich Schwarz laid the foundation for aliphatic fluorine chemistry, or the study of organic molecules with carbon-fluorine bonds. Also, I apologize to all of the prescriptivists out there. He prepared the first CFC, or chlorofluorocarbon, which is CF2Cl2. Also known as Freon 12, this molecule is comprised of 1 carbon, 2 fluorine, and 2 chlorine atoms. Unfortunately, at the time, there were limitations to the synthesis of the molecule, which made it costly. Commercial refrigerants at that point in time remained ammonia, chloromethane, propane, and sulfur dioxide. However, in 1920, our good friend Thomas Midgley Jr. found a way to synthesize CFCs with a much lower cost. If you recall, Midgley is the same individual behind the lead catastrophe video. CFCs very quickly replaced refrigerants and were soon found in foams, aerosols, and other products. The problem with these molecules is that once they are in the atmosphere and mixed into the upper levels, ultraviolet photons can strike the molecule and cleave the chlorine atom right off. The free chlorine acts like a catalyst with ozone and becomes chlorine monoxide with a free oxygen molecule. The chlorine monoxide molecule can then go on to interact with free oxygen atoms, resulting in chlorine and oxygen gas. This means that the chlorine is free to continue to convert other ozone molecules into oxygen gas as long as it's in the atmosphere. This is why CFCs are so damaging to our environment. As chlorine builds in the atmosphere, the rate of ozone depletion increases exponentially. Why is this important though? Who cares about some silly ozone? In other words, what has ozone done for me lately? As was discussed in the greenhouse gas anatomy video, some molecules have the ability to absorb and re-emit electromagnetic radiation. In the case of greenhouse gas molecules, this means infrared radiation. In the same way, oxygen molecules and ozone are sensitive to wavelengths within the ultraviolet region. However, only ozone is sensitive to the most energetic photons. Somewhere between 95 to 99% of the ultraviolet radiation that could harm us is absorbed into the atmosphere, providing us with a stable environment for cell growth. Thankfully, in 1989 we realized the error of our ways and passed the Montreal Protocol on substances that deplete the ozone layer. At first, researchers thought the data were anomalous, and therefore it wasn't really considered something that was actually occurring. However, upon looking into the matter further, we found we were doing great damage to the planet as a whole, and by working together as a species, we averted a human-made disaster. The Earth has enough activity within its atmosphere to get us this far, so continuing to move it away from its equilibrium point doesn't seem like the best idea that humanity has ever come up with. Ignoring the problems that we've created in the past and continue to create isn't a rational or feasible solution to any modern problem. Thanks for watching, and please stay safe, my witchlings. Know that you are incredible, and until next time, bye.